I'm just going to go through question 16 from the AQA Maths A Level Paper 1, 2019, and it's question 16. So here we've got this curve and we're trying to find dy by dx. We can see it's two terms being multiplied. We're going to use the product rule. So dy by dx is equal to first, which is e to the minus x, differential of second, sine differentiates to cos x and cos differentiates to minus sine x. So that's first differential of second plus second differential of first. Now when I differentiate the first, a minus is going to come in front. So I change that to minus, and so it'll be e to the minus x, and then it'll just be sine x plus cos x. So what I can do now is take e to the minus x out, and then I'll have a cos x minus a sine x. This minus will give me another minus sine x, and then a minus cos x. The cos x's will cancel. I'll have e to the minus x times minus 2 sine x, which we can write as minus 2 e to the minus x sine x. So in part A, we just differentiated this down and we got minus 2 e to the minus x sine x. So we know that our question differentiates to that answer, and now it's asking us to integrate something similar. So we know that this is going to integrate back to there, but it needs a minus 2 on the front. So if we gave it a minus 2 there, we know what that integrates to. It's going to integrate back to our original question. But that's not the question we're doing in part B. It's asking us without the minus 2. So if we just put minus a half to compensate for the minus 2 we need, we know that that minus a half is just going to join in. So it's going to be minus a half, and then just back to our original question. So it's e to the minus x sine x plus cos x plus c. So we can see that's just equivalent to this, and the a in the front is just what we've needed to compensate in order to use what we've done in part A. So a is equal to minus a half. On to part C, and we're going to be using the bits and pieces that we found in part A, because here we've got the graph y equals e to the minus x sine x. We can see it goes up and down here. We're trying to find the exact value of this area, so we need to locate the limits because we're going between those 2 points here. So thinking about y equals e to the minus x sine x, it's two things timesing together, and if you equate that to 0, either e to the minus x equals 0 or sine x is equal to 0. Now if you think about e to the minus x, it's just a graph that comes down. It's never going to have any roots, so the points where it goes through the x-axis are going to be dependent on sine x, and sine x goes through the x-axis at multiples of pi. So we've got pi there and 2 pi. So every n pi, this graph is going to go through. So these are the points. Now for area 1, we're just going between 0 and pi. So we're needing to do the integral from 0 to pi of our e to the minus x sine x. Now from part A and B, we know that if we just put a minus 2 there and a minus a half, that is going to be the integral is going to be the minus a half e to the minus x sine x plus cos x. And then just put our limits in, no plus c now because we've got a definite integral. So now putting our limits in, put the top limit in first. You've got minus a half e to the minus pi. Now sine pi is sine 180, which is going to be 0, and cos 180 is minus 1. So that's the first limit in. Second one, minus a half e to the 0 is just going to be 1, and then we've got sine 0, which is 0, and cos 0, which is 1. So this is going to be, minuses here will cancel, and we're going to have half e to the minus pi, and then plus a half, and we can write that as e to the minus pi plus 1 all over 2. On to the second part of C. Now we've just found this first area. A1 is equal to e to the minus pi plus 1 all over 2. Now being asked to find the area of A2 because we need to do A2 over A1 to get this e to the minus pi. So we went through the limits 0 and pi, and now we need to go to 2 pi, the next one along. So we are going to be integrating between pi and 2 pi of our e to the minus x sine x. That we know if we put a minus 2 there and a minus a half, the answer is minus a half e to the minus x sine x plus cos x. Between the limits this time, pi and 2 pi. So putting in our limits, we've got minus a half e to the minus 2 pi. Sine of 2 pi is sine 360, 0. Cos of 2 pi is 1. And then minus a half e to the minus pi. Sine pi is 0 and cos pi, cos 180 is minus 1. We put that limit in on the last one. So tidying this up, we've got minus a half e to the minus 2 pi. These minuses will cancel, but we'll still have a minus from the middle, minus a half e to the minus pi. Now what I can do is take out minus a half e to the minus pi as a factor. I'll need to have an e to the minus pi because these will add together to give me the 2 pi. And then I'll just have a plus 1 because when that minus times is in, I will get the minus. So what I can do now is think of this minus on the front because it is an area underneath. If I just want the exact areas, I can just get rid of this minus and say that it's going to be e to the minus pi, e to the minus pi plus 1 all over 2. So that is the area of A2 rather than the integral. The minus just shows that it's underneath. So A2 over A1, because they have got the letter A, we're looking at the exact areas. We just can do it's A2 e to the minus pi, e to the minus pi plus 1 all over 2. Now dividing by this is going to be the same as timesing by 2 over e to the minus pi plus 1. And see what's going to happen now. The 2's are going to cancel. The e to the minus pi plus 1 is going to cancel, and we're just going to get e to the minus pi, which is what we want. In this last part of the question, we can use the fact that we've just found A2 over A1 to give us e to the minus pi. And then it's telling us in this question, given that whenever we do the one after divided by the one before, we do get that same constant e to the minus pi, we're being asked to find the total area of all these A1, A2s, and so on added together. Now we're just going to ignore the fact that the A2s, A4s, A6 is underneath, so we're going to ignore those negatives, and we are just going to be summing up A1 plus A2 plus A3 and so on. Now when we have done that division here, we can see that how do we get between the terms? It's just going to be here, this constant with times by e to the minus pi. So this is telling us we've got a geometric progression, and also because the graph is e to the minus x sine x, because that e to the minus x is involved, it's never going to reach the x-axis, so it's just going to keep getting smaller and smaller, and it's telling us we need to do a sum to infinity. So what's the formula for that? It's a over 1 minus r. Now our a is equal to e to the minus pi plus 1 all over 2. And our r is equal to, what do we do to get to between the terms? E to the minus pi. So let's just put them into the formula. It's going to be a e to the minus pi plus 1 all over 2 divided by 1 minus r, which is e to the minus pi. So what we can do here is e to the minus pi plus 1 all over 2. Instead of dividing, we're going to times by 1 over 1 minus e to the minus pi, times across the top, e to the minus pi plus 1 all over 2 minus 2e to the minus pi. Now we can look where we're trying to get to doesn't have e to the minus pi, it has e to the just plus pi. So each of the terms in this fraction, there's 4 of them, 2 on the top, 2 on the bottom, we can divide by e to the minus pi. So what you need to do is see an e to the minus pi, an e to the minus pi, an e to the minus pi, oops, and an e to the minus pi under all of those. So that is then going to give us here, they'll cancel and just give us 1. Then we'll have 1 over e to the minus pi, which will be plus e to the plus pi. So just taking that minus pi on the top, and then we'll have 2 over e to the minus pi, which is 2 to the e to the pi, and then we'll have minus 2 because those e to the minus pi's will cancel. And then we've got it, haven't we? It's going to be 1 plus e to the pi over taking 2 out, e to the pi minus 1, and that is what we're trying to get to.